Hey guys, today, before we start our lesson number 5 for Unit 5, we're going to play a little game. I often refer to this game as the X puzzle. All right, the X puzzle. So here's what this puzzle is. Obviously, you see a ginormous X, okay? And then what that X creates is 4 different areas. There's an area on the bottom, an area on the top, and I've written two words there. On top it says multiply, on bottom it says add, subtract, and there should be a slash there. And then you can see that there's a left and a right as well. So the top and the bottom, the red and the blue, that is the puzzle part. And green is going to be our answer to the puzzle. The first number and the second number are the answer to our puzzle. So now let's go ahead and just jump right in and we're going to try this, okay? So I'm going to make a new one over here. So what if I gave you two numbers, okay? Let's say 12 on top and 7 on bottom. And I'm color coding for you because I want you to remember that red is multiply, blue is add or subtract, okay? Your goal to solve this puzzle is to come up with two additional numbers that would multiply to give you the top number, but they would add or subtract to give you the bottom number. So I'm going to kind of walk you through this one, okay? Some people find that the easiest method is to start listing factors of the top number. So factors would be like 12 times 1 is 12. 6 times 2 is 12, and 4 times 3 is 12. And there's no other sets of whole numbers that would give me 12. So now, of these 3 sets of numbers, which ones might add or subtract to give you 7? And some of you jumped right to 4 times 3 is 12, but 4 plus 3 is 7. And that is absolutely right. So if you're going to fill in your puzzle, you would write 4 and 3, and I want you to be sure to note that they're both positive numbers. All right, let's do one that's a little harder. So this is kind of just like brain games right now, okay? We're just playing a puzzle together. So here's my puzzle. Okay, my top number is going to be a 3. No, it's going to be an 18. Negative. And my bottom number is going to be a 3. So can you come up with two numbers that multiply to give you 18 or negative 18, but then add or subtract to give you 3? So some of you want to start out with listing the factors. You can do that physically on a sheet of paper, or you can just do it in your head. Okay, so 18 times 1 cannot add or subtract to give you 3. What about 2 times 9? 9 plus 2 is 11. 9 minus 2 is 7. So that won't work. What about 6 and 3? 6 plus 3 is 9. 6 minus 3 is 3. Ooh, I think that we got it. Right? So in order to make this work, I would have to do a positive 6 minus 3. So my answer would be positive 6 minus 3. Okay? All right. I want to give you one, and as soon as I give you the puzzle, I want you to totally pause this video and see how long it takes you to get to the correct answer without me guiding you there, okay? Let's do negative 8 and 2. Pause. All right, so the answer that I got was 4, a positive 4, and a negative 2. 4 minus 2 will give me 2, but positive 4 times negative 2 will give me negative 8. Hopefully you're able to kind of catch on to this puzzle, okay? If we were in class together, we would be spending like a full 30 minutes and doing some major competition to see who could do this the fastest. And I'd be giving out tiger tickets left and right. So, let's see. Let's do another one. And I want to kind of make it challenging for you. Let's do... Ooh, I got one. Go. And hopefully everybody got 1 times 1 is 1, and 1 plus 1 is 2. That's a tricky one, okay? So whenever there's a 1 involved, it can seem a little tricky. All right, let's try another one. Let's do -3 and -2. Pause the video and try that one. All right, so I got a 3 times 1 is the only way to get to 3, and then you got to decide where the negative goes. So -3 plus 1 is how I get the -2. All right. Let's do, I think we've hit all the different kinds. I think that we've hit all the different kinds. So this is the X puzzle. That's what I call it. Some people call it the X factor because in a minute we're going to learn how to use this to help us factor. But your answer will involve 2 numbers and they both have to have a sign. So if it's positive, you want to put the positive sign. If it's negative, you want to put the negative sign. This is just a reminder to please make sure you complete the teacher working conditions survey. Again, this is a reminder. Please complete the teacher working conditions survey. If you have a paper that has a code that does not work, please let Ms. Pete know so that we can get you another code. Again, please let me know if your code does not work. But again, please complete the teacher conditions working survey. Thank you. All right, now we're ready to go take a look at our notes and see how this X puzzle is going to be used in our notes. So here are our notes. Unit 5, Lesson 5. We are going to be factoring trinomials today. To factor a trinomial in the form x squared plus bx plus c, we have to find 2 integers that multiply to give us c, but add or subtract to give us b. So let's take a look at this guided example. Now over here you can see this X puzzle that looks like what we were just doing. So real quickly, see how long it takes you to get 2 numbers that multiply to give you 12, but add or subtract to give you 7. And yeah, we already did that one together. It should be a +3 and a +4, right? But let's see how this translated. Like, how did I get these numbers from the problem that was given to me and put it into the puzzle? Okay, so the constant term goes on top, and the middle number that you see here goes on bottom of the puzzle. And that's how I fill it in. Okay, so this is the C value, and this is the B value. And I'm getting these letters from the standard form of a quadratic function is x squared plus bx plus c, and this is what a quadratic function is going to look like. We will get into quadratic functions in our next unit. Right now we're building up to learning how to work with them. Okay, so far we've gotten that puzzle. We practiced it, we played with it. I think that we can solve it now. So the only thing new that I've added here is how do we take an equation they give us and fill in the puzzle? The 12 goes on top, the 7 goes on bottom, right? The back number goes on the top. Then we solve that puzzle using our brain. We just solve it. And now I want to show you how we're going to write the final answer. So we found out that our answer is +3 and +4. So that goes in the back down here of these two binomials. And then in the front, I just put an X and an X, and I'm all done. This is my final answer. So if you can master that X puzzle, then factoring these trinomials is super simple. So let's come down to example 1. And we're again going to practice. So which number goes in the top of the X puzzle? And that's the 20. And then in the bottom is going to be the 9. The number with the variable goes in the bottom. So let's find two numbers that multiply to give you 20, but add or subtract to give you 9. And if you need to make a list out to the side, you can. 1 and 20, 2 and 10, 4 and 5. And which of these would be the correct answer? And it is +4, +5. Now what I'm going to do is I'm going to put my answers in here in the back. +4, +5. And this n square that was in the front, I'm just going to break it up. One goes here, one goes here, and that's my whole answer. Let's try number 4. So here's my X puzzle. This goes on top. The middle goes on bottom. And let's try to solve that. The only numbers that multiply together to equal 1 is 1 and 1. And 1 plus 1 is 2. They're both positive, right? And then I have a Y. And then I have a Y. And then they both get wrapped up. And that's the answer. So I really would like to see you try to do a few of these. Just pause the video and see if you can figure them out. Again, if you're searching this topic, it is factoring trinomials. And that is where your A equals 1. And what I mean by that is standard form of a quadratic, there's going to be an A here. Okay, and right now our A values equal 1, meaning the coefficient of the first term is a 1. Notice that in example 1, I just said n squared. That's the same thing as 1n squared, or 1w squared, or 1y squared, or 1a squared, okay? Our a value equals 1 for every one of the problems that we're going to solve today, okay? And this should be, that was going to be a comma. Okay. Alrighty, and so I am just going to fill in a few of the answers here for you. But again, after you've had just a minute to try to solve them. All right, so those are the answers to those 4. And then every single one of these is going to operate in the exact same way. Okay, so there's some really good examples here to try. Let's just do 2 more together, and then I think that we'll be good to go. Let's do, I guess we'll do 14, and we'll do 11. Okay, so the top numbers are what are in the back. The bottom number of my puzzle is what's in the middle. All right, so pause your video for just a minute and see if you can think of the numbers that will work in these problems. So it gets a little tricky when we're dealing with negatives. 7, I'm going to talk about 14 first, okay? I have a positive 49, and 49 isn't divisible by too many things. I got 7 and 7, and I got 1 and 49, and I think that's about it, right? And then I needed to add these numbers together to get to a negative 14. So the only way to do that was to make them both negative. But then I want you to stop and think for a minute. Does a negative 7 times a negative 7 still get you to a positive 49? And the answer is yes. So it is possible to have both of our numbers be negatives, okay? And then 63 was just breaking down the 63. Okay, 1 times 63, 3 times 21, right? These are all really big. 4, nope, not 5, not 6, 7 times 9. Okay, so those were all my options for 63. And then the only ones that I could manage to put together and get to a negative 2 was positive 7 and minus 9. Okay, now I want to do some mixed practice. Again, with GCF. I told you that GCF is going to be first and always for every single kind of factoring problem that I can teach you. So we're going to do just one example with GCF, and then I'm going to let you kind of practice and play and get going on your assignment, okay? So I have a trinomial, okay, in example number 1 here, and I see a 4, a 12, and an 8. So I want to see if I can take something out of all of those numbers, and if I do, what will the leftovers be, right? That's kind of how we do it. So what is the GCF here? And the GCF is going to be 4, okay? So my leftovers, okay, 4 divided by 4 is 1k squared. 12 divided by 4 is 3k, and 8 divided by 4 is 2. Okay, so that is a kind of a quicker way to think of GCF if you're just taking a number out. You could still do that factor tree if you wanted, 12 and then 3 and 4. 8 would be 2 and 4. You can still do it that way if you want to. I'm just trying to kind of speed the process along as we get better about looking for GCF. Okay, now I have a trinomial. It's got a 1 in the front. So let's try this X puzzle, right? I've got this 2 on the top, and this 3 has to go on the bottom. So what are the two numbers that can multiply to give me 2, but add or subtract to give me 3? And that's 2 times 1, where they're both positive, right? So I've got a positive 2 and I've got a positive 1. My variable was a k. Wrap them up. Bring down this 4. A lot of people forget to do that. And that is my whole answer right there. That is all of it. Okay. I now want to go look at number 28. Number 28 with you. So I'm going to do this kind of out the longer way. We're going to do the factor tree. Okay. So I see a 5, which is prime, 15, and 140. So let us do 5 and 1, and then x and y, right? And then 15 would be 5 and 3, and x and y. And then 140, if I took a 5 out of that, let's see, 5 goes into 14 twice with 4 left over, 8. There we go. And then I also has a y. So now I'm going to find the GCF. Everything has a 5. I see a y, and a y. Everything has a y. Does everything have an x? Can I take an x out? Nope, I sure can't. So here's what I have left over. I have 1x squared minus, that sign right there, 3x minus, that sign right there, 28. Okay, so this time my GCF was not just a number, it was also a variable term. Okay, all right, now I'm ready to do my X puzzle where the negative 28 goes on top and the negative 3 goes on bottom. So let's think about all the different ways that you can multiply to get to 28. So I have 1 times 28, 2 times 14, 3 doesn't work, 4 times 7, oops, I wrote a 5, 4 times 7, 5 doesn't work, 6 doesn't work, and we've looped back around to 7. So I know that I've gotten them all. Okay, of these 3, which ones could I possibly figure out a way to put together and get to 3? And it looks like 4 and 7. So what do I have to do to those signs to get to a negative 3? Let's see, minus 7, positive 4. So I'm going to have a positive 4 and a negative 7 in my answer. Bring down an x and an x. And then don't forget to bring down that 5y. And this is the final answer for now. Alrighty, great job today. I know that this is kind of difficult figuring all of this out from home, but again, ask questions on Google Classroom. Let me actually go to Google Classroom for a minute. Okay, every assignment that I post for you, if you click on it and I view the assignment, and here's the instructions, I can see all of your class comments right here. So if anyone has questions, you all can even answer each other's questions, okay? Please be sure that you are doing this, that we're communicating, okay? Alrighty, guys. Until next time.